Hello, Flowerpatch. Okay, yeah, we got some cool stuff today. It's April Fools. Happy April Fools. I'm really happy with what Pierre put together for our Discord. We rebranded into Shroom Patch. Last year we did Cabbage Patch. Honestly, some people seriously fell for it last year. They're like, "What? You guys are giving up weed?" No. Yeah, so and we were doing a little mushroom related contest. We're doing the April Fool's drop where there's three of the unique Shroom Fools cards in our dropper plus like 50 presents every hour and a half, but with only a 10% win rate. I know Dullner already claimed one of the Shroom Fool cards, but I'm not sure where the other two ended up. So that's really great. What I want to talk about today is primarily the server architecture, the way that our service works internally and how it works with the website. I think it's pretty cool and it's designed to be able to scale up over time. It's all on top of Google Cloud Kubernetes. So it's pretty cutting edge tech, and I'm pretty proud of what we managed to create. But before we get into that, let me just very quickly give you guys a sneak preview. I'm not going to play the animation, but I'll give you a sneak preview of our upcoming game content animations made by Duncan Hatch. So, I mean, check out this beauty. This is the Cult of Dave. You know, they're summoning, sacrificing a Nug here. A little bit of foreshadowing, maybe. And then over here, we have Nameless and his monks training hard to be able to stand up to evil. So I'm pretty excited about these graphics. Duncan Hatch is one of our favorite artists. Definitely, if you haven't seen his work, check it out. He posts on Instagram and all over the place. He's been viral on Reddit a whole bunch of times. He's worked with some really big names in the industry. I'm really stoked about this. Really looking forward to it. All right, let me show you a little bit of how the server architecture is set up. And what I've got open here is Sketch. This is my favorite kind of like Adobe Illustrator style product. So it's a vector graphics application, which is something that I've enjoyed, for a very long time. Very quickly be able to create mock-ups, graphics, designs, this kind of thing. You can kind of do some basic image editing, whatever. But yeah, in this case, I'm just going to do a very basic explanation diagram of how our service is structured, how pieces communicate together, and hopefully that'll give you some insight into, like really what goes into it. Okay, let me just draw that out right now real quick. You can watch that and fast forward, and then I'll come back and explain the particular decisions. This is kind of a sketch to kind of give you the idea more than like nitty gritty putting together every single like connection and arrow. But so basically we have a cluster of servers in the Google Cloud. We currently are running on 3 servers that we could easily scale this up to many more. So you arrive at the website. The website is served by the web servers. So this is this part here. That gives you the HTML, JavaScript, CSS, all that stuff for the game client / website. All that's bundled together into one thing. The game client website will for example, like you open the game, it will start periodically asking the web server like, hey, give me the updated game state. Hey, give me the latest changes. Hey, give me the latest changes. Um, so the website would ask the web server for that. The web server would say, oh, this is a request for the game. So it goes down this line and asks the game server like, hey, what's the latest state since this, time in the past since they last checked. The game server says, oh, okay, the latest state is this, and gives it back to the web server, which gives it back to the game client. But, there's many situations where the game server needs to reason about flowers or something else. So the website can, you're at the game client, you want to plant a flower. The web server says, hey, game server, plant a flower. The game server might ask the flower database, which is kind of our live service that can search for flowers, tell you information about them, give you their statistics. It will go ahead and reply with some flower information, and the flower DB itself might actually get it either from Ethereum itself, if we only have the information in Ethereum, or it might use our private database, which I will explain in a little bit. So the game server gets some flowers from the flower DB. It might decide, hey, this flower has finished growing now, so it might use our SendGrid emailer to send out an email to the person. Or alternatively, the game server might say, hey, you just opened a present, and then it will talk to a different server called the dropper, which again has a gRPC API, related to protobuf, which would then go ahead and create that flower, mint it onto, again, the Ethereum blockchain using our Infura Ethereum nodes, and then it would say to the game server, like, yep, here's what I did. The game server would say, yep, okay, that's what it did, gives it back to the web servers pass it back to the game client. So that's the way our network's structured. You'll notice I put this blue border around some of it. The web server acts kind of as the gateway into an internal network. So everything, the Google stuff, the SendGrid stuff, that's all the external internet, and we're just contacting those services. The web server acts as a bridge. So you can't actually talk to the game server, Flower DB, or Dropper directly. It's blocked off. It's firewalled into the internal network for pretty much security reasons. We don't want people making APIs directly to that. We want the web server to be able to load balance and handle those calls. And then separately down here, we have the minter and the flower watcher. So the job of the minter, it's kind of not really connected to the internal network, but it's still inside of that walled garden. Its job is to talk to our Infura Ethereum nodes. It regularly gets updates about what's happened with Ethereum. And then when it notices that people have made payments, it can go ahead and reply with creating a flower or whatever else we want. It's actually very flexible. A person could potentially buy a hat from our store for Ethereum, and then our minter would go ahead and notice that payment happened on the Ethereum blockchain, then go off and, I don't know, start a print somewhere. Maybe it was, this hat at Printful. And then the Flower Watcher is a service that Patch wrote, and its job is to, again, use the Infura Ethereum nodes to constantly watch the blockchain and record flowers that are created. So they're created on the blockchain, then we notice them on the backend server, we write them to our database. That's what powers a lot of the Flower database, this Flower DB service. So, recently I implemented the Flower search functionality, and it's actually out, Canadian. It's actually, been released here to the public site. So when I do something like this, find rarity rare, what this actually does is that's the game client asks the web server, hey, find those flowers, that criteria. The web server goes, asks the Flower DB, hey, do you have any flowers that are rare for this account? Flower DB goes, yeah, here's the list of flowers, returns that to the web servers, which then returns to the game client, which then renders the flowers. So this is it. Very, very kind of big picture overview of how our system works. And you can see, for example, if we wanted to have more Flower DB services, because we need to be able to handle a large volume search, we could easily just scale that up to however many we need. We can add more servers very easily. like physical servers. We can add more instances of them. Some of these things don't scale as well. So for example, the game server, because it's all just kind of one big world right now, there's not a very easy way to break that up into multiple servers that are coordinating. However, as we implement either private instance worlds or multiple continents, then we could have a game server for each continent. And that's a scalability approach. We could easily scale up the amount of droppers we have, but realistically, there doesn't need to be more than one. The only thing that we could do is add more Ethereum accounts so it can do more transactions like kind of in parallel, but that's not really that crucial either. Yeah, okay, cool. So lots of great stuff coming up. Lots of exciting new features. We have still some really crazy partnerships. Probably in the next video or so, I will discuss how we're starting to get into physical dispensaries and partnering with actual physical cannabis stores. That was always a part of the vision. It's very exciting to get started on it. I'm really happy that John, our partner, goes by Kryptonite Coins, is out there and making those partnerships and deals using his connections in the cannabis industry. Yeah, lots of cool, exciting new things. And yeah, we'll also be doing more drops, more giveaways, all that good stuff, crafting, harvesting. But thank you for joining me in taking a look at the architectural review of the project. Hopefully makes you appreciate a little bit of just like how much careful tech went into it and how prepared we are for the future. But for now, signing off. Love you guys. Take care of yourselves. Stay safe.